If you've ever lost momentum staring at a blinking terminal cursor, waiting for local containers to initialize, you know the friction of local development. Application containers are standard practice. By 2026, 88% of developers use them in their workflow. But the actual bottleneck isn't the container itself, it's the hypervisor layer sitting underneath it. This bar chart reveals the structural bottleneck. The Docker Desktop Hypervisor introduces a 2.69 times startup penalty compared to native Linux. This mathematical penalty stretches a simple 20-minute module test into an hour of troubleshooting port conflicts and watching dependencies install. Developers are bleeding highly valuable hours to environment setup and system administration, often out of muscle memory rather than actual project necessity. For local setups, DDEV is the industry standard. It's an open-source CLI that wraps Docker Compose to handle your PHP versions and web servers directly on your machine. On the other side, there is DrupalForge, a free, cloud-based platform operated by a nonprofit that spins up transient environments in a browser, requiring zero local installation. This balance scale graphic illustrates the core dilemma, choosing the feather-light overhead of zero configuration access versus the heavy anvil of deep infrastructure control. Neither tool covers every use case. Professional efficiency comes from matching the weight of your infrastructure directly to the lifespan of your current task. With DrupalForge, the input process removes the hardware entirely. You open a browser window, pick a template from their library, and click Launch. There is no configuration file to edit. As this timeline shows, the outcome takes under 5 seconds. You receive a live, fully configured environment node that branches out with a pre-installed browser-based VS Code IDE and full database access. That speed is vital for transient tasks. If you need to run a quick client demo, teach an educational workshop, or test a module patch, you bypass the setup tax completely. The environment is disposable by design. It also provides an immediate sandbox for 2026 AI tools, featuring dedicated templates like Drupal CMS AI and the Chrome Prompt API. You can experiment with autonomous agents that generate content types, or test local Gemini models directly in your browser without muddying your own machine's architecture. The trade-offs are straightforward. You must have an active internet connection, and you are working within predefined templates, not a blank canvas container built for hyper-customized servers. DrupalForge optimizes exclusively for velocity and collaborative access over absolute architectural ownership. Local workflows with DDEV take the exact opposite approach. The entire environment is isolated and executed directly on your own hardware. Before you can write a single line of code, you must install Docker, manage your YAML configuration files, and ensure your local port bindings aren't already in use. The payoff for that input is complete offline capability and persistent, deeply integrated access to your local file systems. When a project demands highly specific custom stacks, DDEV is essential. Looking at this local computer diagram, you see how it allows precise integration of custom Nginx configs, Solr search indexing, and Redis caching directly connected to your local directories. That deep control lets you seamlessly integrate with your team's existing CI/CD pipelines and manage complex Git hook requirements without leaving your preferred local IDE. You are taking on a significant hardware tax to host all of this locally, which can slow down older machines. But for a grueling 6-month production build, the initial friction of setting up DDEV is a mandatory payment to guarantee long-term environmental stability and total control. This calculation shifts heavily based on your operating system. Windows machines account for nearly a quarter of all DDEV installations, but examining this user base pie chart reveals a hidden tax. Of that Windows segment, 85% cannot run native Docker and are completely reliant on the Windows subsystem for Linux, known as WSL2. That requires a complex pipeline, enabling WSL2, configuring a Linux distribution, and installing DDEV completely inside that virtualized subsystem, an operation that can consume an entire afternoon of troubleshooting port logic is replaced by the immediate OS-agnostic browser access of DrupalForge. Windows users specifically need to audit their setup time to ensure they are actually writing code rather than performing unplanned system administration. In a modern 2026 workflow, These tools are not mutually exclusive. The most efficient teams use them sequentially. Phase 1 starts in the cloud. You spin up an idea in DrupalForge for rapid prototyping, AI exploration, or securing initial client approval. On this flowchart, Phase 2 triggers when you download that known good codebase from the cloud node to your local machine. Phase 3 transitions the project into a local DDEV environment, securing the offline engineering capability required for a production deployment. This hybrid approach secures the immediate velocity of the cloud for volatile early phases, while reserving local control for long-term execution. If you are an educator, a beginner learning the CMS, or an evaluator prototyping features, default to the cloud. Tasks like teaching a class, testing a single patch, or demoing AI capabilities offer zero return on investment for local setup time. Mapping this on our quadrant chart, a quick demo plots low and left. A 6-month custom build plots high and right, demanding local Docker workflows. For Windows users struggling with subsystems, the cloud provides an immediate escape hatch. Stop letting container spin-up times dictate your agility. Use the cloud for velocity, and reserve your local tools for absolute control.